Today we're going to discuss the integration of the rational functions. So let's start with the definition of the polynomials. Do you remember what we call as a polynomial? It's a linear combination of the power functions, right? So we say the polynomial is some function which I obtain by combining linearly the power functions. So this will be an x in the power of n plus an minus 1 x in the power of n minus 1 plus and so on, plus a1 multiplied as x, plus a0 multiplied as x in the power of 0, which is 1, right? So sometimes I just do not write ax here, okay? So can you give me an example of the polynomials? For example, 2x5 plus 3x squared plus 3x plus 5, right? This is the polynomial. Or 3x cubed plus 5. This is another polynomial, okay? So we call the power of the polynomial as the highest power of the highest degree of the power functions, okay? So the degree of this polynomial in our case is equal to the 5, okay? Degree of this polynomial is equal to the 3. What is the degree of this polynomial? Is n, okay? The highest power is called the degree or the power of the polynomial, okay? So we call the rational function as a function which is written as the ratio of the two polynomials, okay? So this is called the rational function. For example, 2x to the power of 5 plus 3x squared plus 3x plus 5 divided to the 3x cubed plus 5 is called the rational function, okay? So we are interested to find the integrals from the rational functions. So let's start with an example. So let's say we're given the rational function in this form. So x squared plus x minus 2. Okay? So if it would be 1 over 2 instead of 5, so let's assume that I would have 1 over 2 here. How I could integrate this? So I can integrate this by substituting rule, right? Because do you see, so the numerator looks like the derivative of the denominator, right? If you take the derivative from the denominator, you will have almost the same function as on the numerator, right? So we can do the substitution. So let's use the substitution by substituting x squared plus x minus 2. And what will be the derivative of the x squared plus x minus 2? 2x plus 1 multiplied to d dx, right? So what is then x plus 1 over 2 dx? So what is the x plus 1 over 2 dx? So this is the half of the du, right? So if you divide both sides of this equation to the 2, you will have du over 2, and on this side you will have x plus 1 over 2 dx, right? So this is du over 2 divided to what? To the u, and integration. So this will be 1 over 2 ln of u, right? Plus the constant, or 1 over 2 ln of 2x plus 1 plus the constant. Okay? So in this case, we were lucky because this function on the numerator is just the derivative of its denominator. Okay? But if I have the different constant here instead of 1 over 2, I cannot use the substitution anymore. Okay? Because I will have additional constant, then, it will be difficult for me to integrate this. So let me write this one more time. So x plus 5 over x squared plus x minus 2. This is my rational function. And the idea of integrating this is to split this rational function into the two parts. So basically write this one rational function as the sum of the two rational functions. Okay? So in order to do this, it appears we need to find the roots of its denominator. Okay, so we need to write this in this form. So x minus 2 plus 2, sorry, x minus 1. Okay, so indeed, the multiplication of the x plus 2 to the x minus 1 will be x squared plus x minus 2. Right? Okay, so first step is to split the denominator to this kind of multiplicand. So now we are going to write this as some constant divided to the x plus 2 plus another constant divided to the x minus 1. Okay? The idea is like this. So I know how to integrate this function, right? What will be the integration of this function? A over x plus 2. What is the integration of the a over x plus 2? A is some constant. It is a multiplied to the ln x plus 2, right? What is the integration of this function? Is b multiplied to the ln of x minus 1, right? So if I'm able to write down this function in this form, and if I'm able to find these two constants, a and b, then I can integrate this, right? So the integration of this one will be the sum of the integration of these two functions, okay? So the only problem is I need to find this a and b, okay? So how to find this a and b? By giving the common denominator, right? Basically, I need to add this term with this term, okay? So do you remember how we need to add the two ratios, right? So they should have the same denominator. So I need to multiply the first one to the x minus 1 and the second one to the x plus 2, okay? Then I will have the a multiplied to the x minus 1 plus b multiplied to the x plus 2 divided to the x plus 2 x minus 1, right? So let me open the numerator, all the brackets on the numerator, and sort them, write them as the proper polynomial, with the x, with the powers of the x, and with the free coefficient. So where I have the x's? So I have the x here and here, right? So what are the coefficients in front of the x? They are a and b, right? So I'm doing this without opening all the brackets and regrouping them again, right? So if you open all the brackets, you will have ax minus a plus bx plus 2, right? Plus 2b, sorry. So if you take out the x from the brackets, you will have a plus b. So what is the free coefficient here? So what is left instead of them? Instead of ax plus bx. So we have minus a plus 2b. This is what is left, right? So divided to x plus 2, x minus 1. So what I want is, I would like to say, hey, these two polynomials, or these two rational functions are the same, okay? So the two rational functions are the same if their numerators are the same, and if their denominators are the same, okay? So do you see that from here, we see that their denominators are the same, right? We need to equalize their numerators. So I need to write, hey, x plus 5 should be equal to x multiplied to a plus b plus 2b minus a. Do you understand this? So the two polynomials should be the same, right? Okay? And we say that two polynomials are the same if their corresponding coefficients are the same at the same time. Okay? So let us write down the definition of the equal polynomials. So let's say you've got one polynomial, an xn plus an minus 1 xn minus 1 plus and so on plus a1x plus a0, and different polynomials with the same function x, with the same variable x, bn x in the power of n plus bn minus 1 x in the power of n minus 1 plus and so on plus b1x plus b0. So we call these two polynomials equal if every corresponding coefficient in the left-hand side is equal to the every corresponding coefficient on the right-hand side. Basically, an is equal to the bn. An minus 1 is equal to the bn minus 1. And so on. A1 is equal to the b1. A0 is equal to the b0. So if all the coefficients in front of the powers of the x are the same, then we call these two polynomials are equal. Okay? So here, you don't have only one system and two unknowns. So, I mean, you cannot solve this by regrouping, by putting this side to the left or the left-hand side to the right-hand side. So you need to equalize the coefficients around the powers of the x and the free coefficients. Okay? So look at this equation. Could you please tell me what is the coefficient in front of the x in the left-hand side? 1. 1. Right? Coefficient in front of the x is 1. So what is the coefficient in front of the x in the right-hand side part? It's a plus b. Okay? So what is the free coefficient in the left-hand side? It's 5. And what is the free coefficient in the right-hand side? So 2b minus a. So I'm calling the free coefficient the constant which doesn't multiply to any power of the x, right? Or to the power of the x and the power of 0. Okay? So I've got the system of two equations and two unknowns. And by solving this, I can find a and b. Okay? So let me do this. So a plus b is equal to the 1 to a to b, minus a is equal to the 5. So if I sum them, what I get? So I will have 3b is equal to 6, right? If you sum them, a and minus a will be cancelled, and you will have just the 3b is equal to the 6. And what is the b? It's 2. You can just put this to the first equation or to the second equation in order to find a. So if the a plus b is equal to the 1, and if the b is equal to the 2, it means that a is equal to minus 1. Okay? So it appears if you write minus 1 divided to x plus 2 plus 2 over x minus 1, what you need to have? You need to have x plus 5 divided to the x squared plus x minus 2, right? So let's just check it quickly. So let's just sum these two polynomials, okay? If you sum this, what you will have? So give the common denominator. So we need to multiply the first term to the x minus 1 and the second one to the x plus 2, right? So we're going to have 1 minus x plus 2x plus 4, right? So 2 multiplied to the x plus 2 is 2x plus 4. Divided to x squared plus x minus 2, okay? So what we have on the denominator? So x plus 5. And on the denominator, we'll have x squared plus x minus 2. Right? So basically, we solved the inverse problem again, right? So we were given this polynomial, and we said, okay, so I don't know how to integrate this one, but if I write this as the sum of these two polynomials, I know how to integrate them, right? Do you understand what is the objective of this method? So if you have the rational function, you need to write this as the sum of the other rational functions, which you can integrate, okay? So now, let's integrate. So the integration of the x plus 5 divided to the x squared plus x minus 2 dx is equal to the integration of the 2 x minus 1 minus 1 divided to the x plus 2. Do you agree? Because they are the same. So this is equal to this one, right? So this will be the integration of the 2x minus 1 minus 1 divided to x plus 2 dx. And we're going to have 2 multiplied to the ln of x minus 1 minus ln of x plus 2 plus the constant. Okay? So this is the integration of this rational function. Good? So today we're going to consider these three different cases. So this is the first case where we can decompose the denominator easily. Okay? So let's consider a different example. An example where the power of the numerator is higher than the power of the denominator. So x minus 1 dx. Integration of this function. Okay? So what is the power of the numerator? And what is the power of the denominator? Is 1. Okay? So we can divide the numerator to the denominator. Okay? If you can divide, if the power of the denominator is more or equal to the power of the denominator, the first thing which you need to do is you need to divide them. Okay? So do you remember how we used to divide the numbers in the school? So for example, if I would like to divide 83 to the 3, what I need to do? I need to multiply the 3 to some numbers in order to eliminate the numbers in the left, right? For example, I need to multiply this to the 2, It will be 6, right? Then I subtract. It will be 23. Then what I need to multiply? To the 7, right? It will be 21. If I subtract this, what I will have? 2. So 2 is the remainder, right? 27 is the answer. So I can write down 83 over 3 as 27 plus 2 over 3. Right? So the same thing I'm going to do to divide these two two polynomials, okay? So if I need to divide x cubed plus x to the x minus 1, then I need to try to get rid of the highest powers one by one, okay? So what I need to multiply here, so that after the multiplying to the x minus 1, I will have x cubed, x squared, okay? Just multiply this to the x squared. So if you multiply the x squared to the x minus 1, what you have? X cubed minus x squared, right? Now we subtract them. If you subtract, what you get? X plus x squared, right? Or let me write this as x squared plus x, okay? So x squared plus x. Good? Now what I need to, so can I divide x squared plus x to the x minus 1? If the power of this polynomial is bigger, you can always divide them, okay? So if you divide this, then you need to get rid of the x squared, okay? So what I need to multiply here, what I need to put here, so that its multiplication to the x minus 1 will eliminate this x squared, or will give you x squared, just the x, right? Plus x. Plus x. If you multiply the x to the x minus 1, what you get? X squared minus x, right? If you subtract, then what you get? 2x. Right? So what is the power of this polynomial at the end of the tx? What is its degree? It's 1. What is its degree? 1. We can still divide. Okay? So unless the power of the numerator is more or equal, you can divide. Okay? So what I need to multiply, what I need to write here, so that after multiplication to the x minus 1, it will eliminate this minus tx. It was plus tx, right? Plus tx, sorry. So I need to write plus what? 2, right? So now let's multiply the 2 to the x minus 1. What you have? 2x minus 2, right? If you subtract, what you get? Plus 2, right? So what is the power of this 2? Is 0. The power of the x minus 1 is 1. You cannot divide this, so that is why this is the remainder. Okay? Analogously as we did here, we wrote down 83 over 3 as the answer, as the 27, right? Plus the remainder divided to the still 3, right? So in the same manner, I can write this here. So I can write x cubed plus x divided to the x minus 1 is equal to the answer, right? X squared plus x plus 2 plus the remainder divided to the x minus 1, right? So do you see the similarity between this and this? Yes? So 83 over 3 is 27 plus the remainder, which is 2 divided to the 3, right? So x cubed plus x divided to the x minus 1 is our answer, x squared plus x plus 2 plus the remainder, which is 2 divided to the x minus 1. Okay? Good. Then the integration of the x cubed plus x divided to the x minus 1 dx can be written as the integration of x squared plus x plus 2 plus 2 divided to the x minus 1 dx. Can we integrate this? Okay, so this will be x cubed over 3 plus x squared over 2 plus 2x plus 2 multiplied to the ln of x minus 1 plus the constant. Right? Okay. So if you're given the polynomial, if you're given the rational function, and if the power of the numerator is bigger or equal to the power of the denominator, you need to try to divide this unless the power of the numerator gets smaller. Okay? Once it's smaller, then you need to use the first method with the coefficients, with splitting the rational function to the several parts. So let's do one more exercise. So let's integrate x squared plus tx minus 1 divided to the tx cubed plus 3x squared minus tx dx. Okay? So what I need to do, first of all, what was the first step? Step number 1. Okay, after checking. Okay, so step 1, step 0. Check the powers, right? What is the power of the numerator? Is 2. What is the power of the denominator? Is 3. I cannot divide them, right? Because the power of the numerator is smaller, okay? So step 1. We need to find the roots of its denominator, okay? So let me take out dx from the brackets. I can write as x multiplied to the tx squared plus 3x minus 2, okay? Then we can further decompose this to the x multiplied to the tx minus 1 to the x plus 2. Okay? So by finding the roots, I can write it like this. Okay? So if you multiply all of these 3 parts, all of the 3 terms, you will get exactly tx cubed plus 3x squared minus tx. Okay? Now, step number 2. Yes. So step number 3 is to write down the rational function x squared plus tx minus 1 divided to the x, tx minus 1, x plus 2. In which form? In the form a divided to the x plus b divided to what? Tx minus 1 plus c divided to the x plus 2. Okay? So you need to understand that in the left-hand side, I've got one rational function, and on the right-hand side, this is another rational function, okay? So you need to bring this in the form like a one polynomial divided to the second by giving the common denominator. Then you need to equalize the polynomials on the numerators by equalizing their corresponding coefficients. And once you find a, b, and c, you can integrate the 3 terms, and integrating of the 3 terms will be equal to the integration of this one on the left-hand side. Okay? So let's find A, B, and C. So in order to find the A, B, and C, do you understand what we're doing? Right? We are basically given the answer, right? So previously, what we did is, if you're given like a one rational function and the second rational function, you always try to simplify them by adding them, right? So now, you're given the answer, the addition, and I'm asking you, hey, give me like a defactorize them, okay? Give me the 2 rational function or 3 rational functions so that their sum will give me this answer. Okay? So in order to find A, B, and C, first of all, we need to add them. Add all of the 3 terms by giving the common denominator. Okay? What is the common denominator? Is this term, right? So what I don't have here on the first term? Tx minus 1 multiplied to the x plus 2. What I don't have on the second one? X and x plus 2. And on the third one, x and tx minus 1. Right? Okay. So I can write this as a multiplied to tx squared plus 3x minus 2. I just multiplied the tx minus 1 to the x plus 2. Okay? So plus b multiplied to the x squared plus tx plus c multiplied to the tx squared minus x. Okay? This is the numerator on the left-hand side, right? So now, instead of regrouping them by taking out the coefficients a, b, and c, I need to regroup them by taking out the x squared, x, and the free coefficient, right? Because I need to compare this with this polynomial, right? Okay, so you can do this in 2 ways. Either you open all the brackets, then you will find all the coefficients with the x squared, with the x, and the free coefficient. Either you can try to do this automatically without opening the brackets. Okay? So we need to find all the terms with the x squared. Where I have the x squares? I have the x squared here, here, and here. Right? If you open the brackets, you will have 3 terms with the x squared. Right? So let me take out the x squared and write down the coefficients in front of the x squared. So if you open the first bracket, what will be the coefficient in front of the x squared? 2a, right? 2a. What will be the coefficient in front of the second x squared? Plus b, simply b. What will be the coefficient in front of the third x squared? 2c plus 2c. Okay? Now let us find the terms with the x. So where I have the x? I have the x here, here, and here, right? So if you open all the brackets and regroup them by taking out the x from the brackets, what you will have the coefficient in front of the first x? 3a. In front of the second? 2b. In front of the third? Minus c, right? So what is left? Is this term, and that's it, right? So I have minus 2a. That's it. So this is my polynomial, right? So this should be equal to what? To this polynomial, right? Basically, x squared, or let me write this like x squared plus 2x minus 1 should be equal to x squared multiplied to the 2a plus b plus 2c plus x multiplied to the 3a plus 2b minus c minus 2a, right? So we, again, say that the two polynomials are the same if the coefficients of these polynomials are the same, right? So what is the coefficient in front of the x squared on the left-hand side? Just 1. In front of the x squared, 1, right? What is the coefficient in front of the x squared on the right? 2a plus b plus 2c. What is the coefficient in front of the x on the left-hand side? Sorry, it's simply 2. And on the right-hand side, 3a plus 2b minus 3. What is the free coefficient in the left-hand side? On the left, minus 1, and in the right-hand side, minus 2a, right? Okay. So from the third equation, so basically you've got 3 equations and 3 unknowns. By solving the system, you can find a, b, and c, right? Okay. So let's find a from the last equation and substitute this as the first 2 equations. Okay. So what is a from the last equation? 1 over 2, right? If you substitute 1 over 2 instead of a on the third equation, it will be true, right? It will be satisfied. Now let's substitute a is equal to the 1 over 2 to the first equation and to the second equation. Okay? So this is 2 multiplied to the, instead of a, I need to put 1 over 2, right? 1 over 2 plus b plus 2c is equal to the 1, right? So on the second equation, 3 multiplied to the 1 over 2 plus 2b minus c is equal to the 2, right? So what is 2 multiplied to the 1 over 2? Is 1. So this one and this one will be cancelled, right? And you will have b plus 2c is equal to the 0. What is the 3 multiplied to the 1 over 2? It's 3 over 2, 1.5, right? If it goes to the right, it will be just 2 minus 1.5 is 0.5, right? So 2b minus c is equal to the 1 over 2. Do you understand this? Yes? I just substituted the a to the first equation and to the second equation. Now I've got 2 equations and 2 unknowns, right? So how I can find this? So for example, I can find a b from the first equation and substitute this as the second equation, right? So what is the b from the first equation? Minus 2c. Let's substitute this to the second equation. It will be 2 multiplied to the minus 2c minus c is equal to the 1 over 2, right? If you open all the brackets, what you will have? Minus 5c, right? So minus 5c is equal to the 1 over 2. So that is why c is equal to minus 1 over 10, right? I need to divide both of the sides to the 5, right? Minus 5, sorry. Okay. If the c is equal to the minus 1 over 10, and a is equal to the 1 over 2, what is the b? So b is equal to the minus 2c, which is equal to the minus 2 multiplied to the minus 1 over 10, right? So this will be 1 over 5, okay? So now I know what is the a, what is the b, and what is the c, right? And by putting the a, b, and c to here, I can find this integration, okay? Let's put them, all of them there. So 1 over 2 divided to the x plus 1 over 5 divided to the tx minus 1 plus minus 1 over 10 divided to x plus 2. So this is equal actually to our original polynomial, right? So it was x squared plus tx minus 1 divided to tx cubed plus 3x squared minus tx. Okay? So if I need to integrate this polynomial, then I can just integrate these three polynomials and sum them. The answer will be the same. Okay? Now let's integrate them, which is like more or less straightforward, right? So what is integration of the 1 over t, 1 over x dx? Is 1 over t ln of x. So what is the integration of the minus 1 over 10 of the 1 divided to x plus 2? Is minus 1 over 10 ln of x plus 2. Okay? And what is the integration of the 1 over 5? Integration of the 1 over tx minus 1 dx? 1 over 10. Good. Good. 1 over 10 ln of tx minus 1. Right? Plus the constants. Okay? So do you understand where this 10 comes from? Because of this t, right? Because of this rule. So if you have to integrate 1 over x plus 1, then this will be simply ln of x plus 1, right? But if you would like to integrate 1 over kx plus 1 dx, so this will be ln of kx plus 1 divided to the k, right? This will be the ln of kx plus 1 divided to the k because of this k, right? Because once you take the derivative from this part, it will be 1 over k plus 1, kx plus 1, multiplied to the derivative of this one, according to the chain rule. What will be the derivative of this one? Is k, right? And this will be cancelled with this 1 over k, and you will have exactly this function. Okay? So this was the first part.